All right, Matthew, here we go. We got lesson 9.3.1, average rate of change and projectile motion. We did a water balloon thing in the first semester, so we're going to kind of come back to that. Maggie's water balloon is launched into the air, and we've got the data for the height compared to the time. Okay, so the first thing that we're going to do is graph the data. And when you graph data, and you just have a blank sheet like this, what you're going to want to do is look and see what your maximum is going to need to be on the y-axis and what your maximum is going to be on the x-axis. And let that determine the scale of your graph. So I can see that I need to go to 90.5. So maybe I'll do everything by fives on the y-axis. Whereas I only have to go to 4.5 on the x-axis. So maybe I'll do it by every half second as I do that. All right, so keep that in mind as you do this if you're doing it at home. I'm going to go ahead and graph it. I'll pause right now, and we'll see what my graph looks like after I've finished. All right, so here we go. We've got my graph there, and you can see that it kind of looks like a parabola, which makes sense because gravity makes stuff go back down after it goes up. So there we go. We've got all of our stuff graphed. Now on to the questions. Calculate the average rate of change between 0.5 seconds and 1 second. Now, since this is not a straight line, it's a curve, this means that the speed is constantly changing. Like it starts off fast, it slows down, gets to the top, and then changes direction. So then we have a negative speed or velocity over here. So we got a positive velocity here, it goes fast. When it gets to the top, it's going 0. And then it turns around and it gets a negative velocity going in the other direction. It goes faster and faster and faster until it hits the ground. So we can't really calculate well, I mean we can, but we're not going to. We can't calculate the exact velocities. We're going to find the average velocities during certain points. So we're going to start with 0.5 seconds and 1 second. So here's 0.5 and 1 right here. So I'm going to do 60.3. I'm going to subtract 34.2. That's the distance that it went from half a second to a second. And then it's always the velocity would be the distance divided by the time. So the time between these ones would be 1.0 minus 0.5. So you take the last number and then subtract it from the first number there. So here I end up with, let's see, 60.3 minus 34.2, 60.3 minus 34.2, 26.1 divided by 0.5, and it comes out to approximately 52.2. So 52.2, the numerator is in feet, the denominator is in seconds. So it's going approximately 52.2 feet every second from this second onto this second. Now remember, it's going to go faster at the bottom, slower at the top because of that curve that we've got there. So we're just really estimating the time here between these 2 points. So we're estimating at 0.75 seconds about how fast was it going. All right, calculate the speed of the balloon at 1.75 seconds. So we want a time right before and a time right after of 1.75. So we're looking at over here between 1.5 seconds and 2.0 seconds, that would be 1.75 seconds. So if I can find the average between these two numbers, that'll give me the average rate of speed at 1.75. Is it exact? No, we're just finding an average rate for that speed. So I'm going to do 88.4, subtract 78.4, and then divide 2.0 minus 1.5. So this is the change in the feet. This is the change in the seconds. I end up with 10. Yeah, that's 10 on top and 0.5 on the bottom. So 10 divided by 1/2 is 20. So now we are going 20 feet per second. So we're going slower at this point. And we can tell that we're going slower because we can see this curve is starting to turn here. It's becoming less steep. So we just found between 1.5 and 2. So basically in between there's where 1.75 would be. And we're just looking at that speed kind of in this section right here. So that's its average speed. Now the balloon hits the ground at 4.8 seconds. That's right about here. So if the balloon hits the ground at 4.8 seconds, well, this is a parabola. So if it started at 0, went up and came back down, halfway is where it should be at the top of its arc. So we want to know when it achieved its maximum height. So half of 4.8 would be 2.4. So it looks like at 2.4 seconds, it reaches its maximum height. What was its speed at 2.4 seconds? Well, that's when it's changing directions. So its speed at 2.4 seconds should have been 0 feet per second. It wasn't going any speed at all at that point. What was the velocity of the balloon when it hit the ground? All right, so maybe I would take the difference between this point right here, which is 4.8, and the closest point that I have over here is 4.5. So I know that at 4.8, it hits the ground, so its height is 0. So I'm going to do 0 minus 18.8. And then I'm going to do 4.8 minus 4.5. So I end up with negative 18.8 over 0.3. And then 18.8 divided by 0.3 ends up being 62.7, but it's negative. We get negative 62.7 feet per second. Our velocity is negative because we are coming down now. We had a positive velocity going this way, and now we're going the other direction, so we have a negative velocity. Notice it's going a lot faster than these other times that I came with because it is about at its fastest point here. All right, now we have used the graph of Jen's balloon on the back page to answer the following questions. What was its velocity at 1 second? Let's flip over and see what hers looked like. So velocity at 1 second. So if we're going to find the velocity at 1 second, we need to find the average by finding time on either side of 1 second. So maybe we use half a second and 1.5 seconds to find 1 second. Does that make sense? We go on either side. So let's start with 1 second. Was it 1 second? Yeah, it's 1 second. I was supposed to do 2 seconds. I think that was what the book said to do. Let's change it. The book says 2 seconds. I have a typo here. So at 2 seconds, let's do 2. All right, so between 2 seconds, we'd go between 1.5 and 2.5 to find the speed at 2 seconds. So 2.5 way up here. 2.5, it looks like the speed, I'm going to call that 96. All right, and then the speed at 1.5, or the height at 1.5, sorry, I keep on saying the wrong words. So right here, that looks like at that point that we've got, let's see, this is 85, let's call that 82. All right, so the difference between 96 and 82 and then the time difference was we found the time between 2.5 seconds and 1.5 seconds. So 96 minus 82 ends up being 14 over 1. So it looks like it's going 14 feet per second because we just found the average between these 2 points. Is that really where it's at? Probably not, but it's close enough. So at 2 seconds, we got 14 feet per second. Okay, average velocity at 2.5 seconds. So in order to do 2.5 seconds, so here's 2.5, we're going to need to find the height at 2 seconds and at 3 seconds. And then find the average between those. So here's 2 seconds right here. That's this point. Oh, let's just call that 92.5. And then here's 3 seconds right here. And I'm going to call that 91. All right, so I've got 91. Let's call this 93 just to keep our numbers nice. Let's call it 93 for funsies. So 91 minus 93. And we did 3 seconds minus 2 seconds. So in the numerator, I've got -2 over 1. So it looks like I've got -2 feet per second. Because at this point, it's starting to go down. Not very fast, but at this point, we can see it's not the top. Here's the top of the parabola. So at this point, we can see the speed starting to go down, but not very fast. So there it's going -2 feet per second. All right, 4 seconds. All right, so at 4 seconds, here's 4 seconds over here. That means I'm going to look at 4.5 seconds and 3.5 seconds. So here's 4.5 seconds. I'm going to call that, let's call that 38 or 28. And then way up here, let's call that, how about 78? How do you feel about that? 78? Sounds good. All right, so I'm going to do 28 minus 78. We're going to get a negative number here because it is decreasing in height, so we've got a negative velocity. And so we end up with -50. So it's between these 2 points. That's where 4 seconds was. So we're going to estimate that the velocity is -50 feet per second. So it's going pretty fast because it's getting near the ground at this point. And finally, what is the velocity at 0.1 seconds? That's kind of nasty. So let's go back to the page, 0.1 seconds. So maybe I'll do between 0, 0. So that's 0. And 0.1, let's see, this is 0.25, so 0.1 would be about right here-ish. I'm going to call that, oh, wow. I'm going to call that right about here. Maybe here. I don't know, let's call that 8. So we're going to say that this is 0.2. Right about here would be 0.2. That's about right there. We'll call that 8. So we're going to do 8 minus 0. And then we're going to do 0.2 minus 0. So we get 8 over 0.2. And 8 divided by 0.2 is 40. All right, so we get 40 feet per second. No. Wait, 8 divided by 0.2. 40. All right, 40. I think I did something wrong there, but let's just go with it and move on. I'll probably figure out what I did right after I log off. All right, what's the domain and the range as the height increases? So as the height increases, our domain, this is our possible x values. So the domain for increasing. Our domain is our possible x values. Let's look at the graph and see when it increases. So looking at my graph, so I want to see when am I increasing? I'm going from 0 seconds and all the way up to here. It looks like the top of my graph is about, I'm going to call right about there-ish. And if I go down to the bottom of my graph, I'm going to call that 2.4 seconds. So that's at 2.4 seconds. Now that height would probably be a little bit over 96. We'll just call it 96. We'll say it's about 96. So our domain is talking about our x values, our seconds. So I'm increasing until I get to 2.4 seconds. And then after 2.4 seconds, I decrease. My heights, my range, goes from 0 all the way up to 96 and then comes back down. So let's look at this part here. So for my domain, I'm going to say that my x values go from 0 less than or equal to x less than or equal to 2.4. Those are the x values when I'm increasing. When I'm decreasing, my x values, my domain, is going to go from 2.4 and then it crashes to the ground, I think, at 4.8 seconds. So those are my possible x values. From 0 to 2.4 seconds, we're increasing. From 2.4 seconds to 4.8 seconds, we're decreasing. Our range, it looks like we start on the ground, so that's 0 feet. And then it looks like we rise all the way up to about 96. And that'd be my range. And then for the decrease, it's the same thing. It goes from 96 down to 0. So our range would also be for those numbers, 0 less than or equal to y less than or equal to 96. This one's really bothering me, 0.1 seconds. What did I do wrong there? I don't know. We'll have to see. I'll make a separate video and figure that out. All right, so there's all the math that we got for today. We'll come back and talk. Wait. Nope, that's not what I did wrong. I'm going to blame it on the graph. Anyways, all right, so have a good day. I will see you later. Oh, I think I was supposed to be up here instead. That's what. Yeah. Oh, there's 0.2 right there. That's why. 0.2 should have been, because this is 2.5 right here down the middle. I didn't go up high enough. 0.2 probably should have been here instead. That's what I did wrong. So we should have had a height of 16 feet. All right, so that's why we probably use lattice points. We use these lines because sometimes eyeballing it is a little bit hard. So we should have done 16 divided by 0.2, and we would have gotten 80 there instead. That's my problem. All right, I knew I'd figure it out. All right, math hard. I'll see you guys later. Bye-bye.